So today we are going to start with the gravitation, which is from mechanics 2, and so the first unit of this mechanics 2 is a gravitation. So generally students misconcept that this gravitation is only related to the Earth's gravitational field. Suppose this is a Earth, and whatever force is applied by this Earth on any of the particle, whether it is a satellite, whether it is a human being, or whether it is a ball, anything like that. So the force applied by the Earth on any object which is at a certain height from the Earth's surface, that is only the gravitational force. So this is how students misconcept with the gravitation. Actually, if there is any body, any two bodies in the universe, okay, of the masses m1 and m2, any two bodies, so this gravitational force field is not only related to the Earth. If there are any two objects in the universe which are having masses m1 and m2, then the gravitational force field between them, it is given by F is, so this force is directly proportional to m1 m2 upon r square. This is a formula which we have seen from the 12th standard. Okay, but the gravitational force field, it exists between the sun and the different planets revolving around it. Okay, the Earth and the moon, or any two objects which are having masses m1 and m2. Okay, there is a gravitational force field. And what is the origin of this gravitational force field? This is nothing but the mass. The heavier body or the more massive body will have more gravitational force field. For example, if the sun is there, sun has a more gravitational force field, so that it can hold 8 to 9 planets in its gravitational force field. Whereas Earth, which is very small in comparison to the sun, so it can hold only the moon in its gravitational force field. Okay, so the massive the body, more is the gravitational force field. Okay, if the masses of the two objects are more, then its gravitational force field will be more. So mass is the origin for the gravitational force field. Suppose if you see, or if you take a bucket and if you add some detergent into it, and if you make a foam, okay, then you can see that if there is a bigger bubble, then smaller bubbles come and attach to it. That is due to the gravitational force field. And as the gravitational force field of this bigger bubble is greater, the smaller objects or the smaller bubbles will attach to it. If you take a bigger liquid drop on any surface, and if you put a small drop near to it, it will get attracted to it. Okay, so this is also due to the, as the mass of this liquid drop is greater, its gravitational force pull will be greater than this a smaller drop, and it will be getting attracted towards the bigger drop. So the origin of the gravitational force field is mass. If mass is greater, then its gravitational pull will be also greater. If this is a sun, okay, so its gravitational force field will be greater, like this. If this is the Earth, its gravitational force field will be smaller as compared to the gravitational force field of this sun. Okay, so the heavier the mass, greater will be the gravitational force field. So the Newton, for the first time, he found that if there are any two objects in the universe having masses m1 and m2, the force applied by this mass on this mass, or this mass on this mass, that is directly proportional to the m1 m2 upon r square. Okay, the force is directly proportional to the masses, but obvious it is true, because if you take a greater mass, so the numerator will increase, the mass will increase. But this it is inversely proportional to the square of the distance. Suppose if you reduce the distance between the two masses, okay, so it will apply more force on this m2, and as the distance of this m1 and m2 goes on increasing, okay, suppose now this is m1 and m2, so this force applied by this m1 on m2 will go on reducing, because there might be the only this much amount of the force field of this particle and this much amount of force field of this particle. Unless and until these fields interact with each other, they will not apply some force on each other. Okay, and as the distance goes on increasing, the force applied by one particle on the another particle or one body on the another body will go on reducing. Okay, so this is what Newton's law says, and this law we have studied from the 12th standard. And if you try to remove this proportionality sign, so it will be G m1 m2 upon r square, where G is this gravitational constant. Now this gravitational force field is a central force. Suppose there is any body of mass m, and if there is another body, if it is having its gravitational force field like this, okay, if another body is entering here, okay, so whatever force felt by this particle, or if this is a small mass m2, suppose this is a mass m1, and whatever force felt by this m2, that force is a central force. What is the meaning of this? So the force depends only on the distance between these two objects. It is independent of theta and phi. It means that whether the particle is coming from this side, whether the particle is coming from this side, or the particle is coming from this side, okay, the force felt by this m2 particle, that is only dependent on the distance between these two objects. So this force is only the function of distance between the two particles. So such a type of forces are called as a central forces. For example, if you have candle here, and if you are taking your hand near to this candle, okay, so the heat felt by your hand is a function of only distance from this candle. Okay, whether your hand is coming from this side, or whether your hand is coming from this side, or whether it is coming from this side. So the distance between your hand and the candle will decide the intensity felt by you, or the warmth felt by you. This is called as a central force. It is independent of in which direction your hand is coming. Okay, so the such type of forces which are function of only distance. So these type of forces are called as a central forces. So the gravitational force field is a central force. So whatever force felt by the another object, it is a function of only distance, and it is independent of theta and phi. It is independent on the angle from which the object is coming. It will be the function of only distance. So this type of forces are called as a central forces, and the gravitational force field is a central force. Almost electromagnetic force or nuclear force also, up to some extent, it is also a central force. Okay, so the concept of the central force is very important. The forces which are function of only distance, so these forces are called as a central forces. So this is a mathematical representation of the central force, which is a function of only r. So this central force is irrotational force. So this tau is equal to 0. Okay, or we can write this dl upon dt is equal to 0. So if this is the case, then the force is called as irrotational. So this gravitational force, so these are the properties of the gravitational force. This force is a central force, and it is also irrotational force. So we can write this couple of torque acting on or required for the rotational motion. So this tau is given by dl upon dt, where L is the angular momentum. I can write this L d by dt of r cross p, and so this whenever there is a multiplication inside this derivation, we can write this r into dp upon dt plus P into dr upon dt. So let us just put the value of P is equal to mv. We know that P is a linear momentum. If m is the mass and v is the linear velocity of any object, then a linear momentum P is given by P is equal to mv. And this is the angular momentum L, and L is given by r cross P, where P is the linear momentum. This is the relation between the angular momentum and a linear momentum. So let us just put the value of this P as mv plus P. Let this dr upon dt is v, and let us put this value of this P is equal to mv cross dr upon dt. This is nothing but v. So dr upon dt is nothing but rate of change of displacement with respect to time, which is v, and we know that the cross product of any vector with itself is equal to 0. Therefore this term will become 0. So if I take this m, so as this m is constant, into r into dv upon dt, plus this term will become 0. So I can write m into r dv upon dt is nothing but acceleration. So a is acceleration is nothing but the rate of change of velocity with respect to time, and I can write this r into m into a. So force is nothing but mass into acceleration. So let us put this value as r into f. Now we know that this force is a central force field, and it is represented by r into f of r. So if I write it is r into r f of r. So again these two vectors, we know that the cross product of the vector with itself is equal to 0. So this term will become 0. So we can write that, so this tau is equal to 0, or I can say that this dl upon dt is equal to 0, or when the derivative of some term is 0, then that term is said to be constant. So the angular momentum is constant, dl upon dt is 0, therefore L is equal to constant. But this type of a force is called as a irrotational force, because in this forces this tau value is coming to be 0. Now we can also calculate this L. It is given by r cross P. If I put the value of this P as mv, and if I put again the value of this v as r omega, so I can write it r omega. I can write this L in a different form as mr square omega. So this is nothing but the angular momentum in an irrotational central gravitational force field. So the moral of the story of this lecture is, so Newton first time gave the gravitational law, which says that in universe, if there are any two bodies of masses m1 and m2, the force between them is directly proportional to their product of their masses, and it is inversely proportional to the square of the distance between them. So this originates from the mass. Greater the mass, greater will be the gravitational force field of that body. This type of force is a central force, which is a function of only distance, and it is independent of theta and phi. This force is also irrotational. Irrotational means this torque is equal to 0, or we can say that this angular momentum is constant, and this angular momentum is nothing but mr square omega.